so let's get started. All right, so let's talk about the complex zeros and the fundamental theorem of algebra, okay? So let's look at the fundamental theorem of algebra on page 210. In the middle blue box, there is the fundamental theorem of algebra. It says a polynomial function of the degree n has n complex zeros. Some of these are real, some of them are not, okay? Some of these zeros may be repeated, okay? In other words, if you have a polynomial x cubed plus 4x squared minus 8x plus 16, okay? You are going to have three solutions. You're going to have three zeros because it's n to the, because you have the third degree. So you're going to have three of these, okay? Some of them are real, some of them are not, okay? Some of them are going to come with complex numbers. Some of them are going to be a real number, okay? So this is what I said prior, back in 2.4, said that at most, you can have up to three real solutions here, right? You can have up to three zeros, up to three real zeros, right? But you'll always have three zeros if you count the complex ones also. And that's what the fundamental theorem of algebra is saying, okay? It's, again, it says a polynomial function of a degree n has n complex zeros, okay? Some of them are real, some of them are not, okay? Okay, so that's that. And then right underneath there is the linear factorization theorem, okay? If f of x is a polynomial function of the degree n is greater than 0, then n has precisely n linear factors, okay? In other words, if I had, let's see, f of x, again, let's go back to what we had, x cubed plus 4x squared minus 8x plus 16. If I found that I had if I had z1, z2, and z3 as my zeros, I can rewrite this as x minus z1, x minus z2, x minus z3. Okay, and that's what the linear factorization theorem is saying. I can rewrite my zeros in a linear factored, okay, form like this. Okay, so that's what that is saying. Like, one thing to note here is that if you have a leading coefficient, okay, that is a x to the n plus a, I don't know, so we'll just call these, we'll just kind of make this up as we go, bx n to the minus 1 plus 2 all the way down to c, I mean, we'll call it d, I don't even know what it is. So if this a here, the linear factorization, when you do a linear factorization, that a reappears in front of the linear factorization. So if you look at it says f of x equal to a times x minus c1 times x minus z2, x minus z3. Because you have to have that a for the leading coefficient to be the same, correct? So make sure you understand that a thing there, okay? Page 211, the fundamental polynomial connections in the complex case, okay? The following statements about a polynomial function f are equivalent if k is a complex number, okay? So this complex number could be a 2 plus 1i or 2 plus 3i, or it could be just 2, right? Okay. So 1, x equal to k is a solution. Okay. 2, k is a zero of the function. Also, x minus k is a factor of f of x. Okay. And you have to use that, or you could have used that in one of the questions in the test, right? Okay, so let's go ahead and see if we can do number 1, example number 1, and using these things. Example number 1, write the polynomial function in standard form. Standard form. So a f of x is equal to x minus 2i, x plus 2i. Okay, we're just gonna do them out, right? So I'm gonna get x squared, and here I get minus 2ix, and here I get plus 2ix, so they're gonna cancel out. So I'm not gonna write them. And then here, if I multiply these two, I get minus 4i squared, where I squared is minus 1. So this becomes x squared plus 4. Okay, so x squared plus 4 factors out in this fashion, is what it's saying. Okay, B. F of x is equal to x minus 5, x minus root 2i, x plus root 2i. Okay, so here, again, we're going to just do this out because we want it in the standard form. Okay, now it's obvious, or it should be obvious to you, that you want to multiply this to this guy first, because these two both contains I, whereas this one does not. Okay, plus it's plus or minus 2i, so they're the conjugates, right? So that there's some obviously good things for us could happen here, right? So we're going to leave the x minus 5 as it is. Do the same thing as we did in A, so I get x squared here. Then I have x, now if I do this, I get plus root 2i, and I go here, I get negative root 2i, so those two cancel out. Then I have this guy here, so I'm going to have negative root 2 times root 2, which is 2i squared, right? Where I squared is negative 1. So I'm going to go ahead and just change this to the negative 1, cancels out with a negative in front here. So I go like this. Okay. So from here in Algebra 2, you are taught to just go ahead and do them out, collect the like terms, and then put them together, right? So we're in honors pre-calc here, so we're going to do this a little different. The way I prefer to do this is that we're going to go ahead and do this, and we're going to get the x cubed. Then I'm going to look for ways to get x squared. Okay, there's only one way here to get an x squared, right? And it's this guy here. That's the only way I'm going to get an x squared. So I'm going to say minus 5x squared. What about x's? The only way I can get an x is from here to here, right? This is the only way I'm going to get an x. There's no other way. So it's going to be plus 2x. And I have negative 5 times plus 2, which is negative 10. And there I have it right off the bat in a standard form. Okay? This comes in particularly handy when you have other times when they cancel out and you have to combine things, okay? And we'll do that further, okay? So that's B. So I do B. Okay, let's see if we can do C. C, we have f of x is equal to x minus 3, x minus 3, x minus I, x plus I. Okay, obviously, again, we're going to do these two together. Okay. And we're going to have to do these two together, so I'm just going to go ahead and do these two together right now. This is what? X minus 3 squared, right? And then x squared minus 6x plus 9, right? Over here, I'm going to get x squared. The minus ix and the plus ix are going to cancel out. I get minus I squared, where I squared is minus 1. So again, I'm going to go ahead and call this plus 1 because it's minus I squared. Now here we go. Okay, so let's do what we did before. Okay, I get x to the 4th. This is only one way I can get x to the 4th. X to the 4th. X cubed. How can I get x cubed here? I can get it from here and here. And that's the only way. So it's minus 6x cubed, x squared. Okay, there are several ways I can get x squared here. Well, actually, 2 ways, right? From here, I multiply to this, I get 1. Here I get this, I get 9, right? So 1 plus 9 is 10. 10x squared, right? And as far as x goes, there's only one way. I multiply this guy to this guy, so it's minus 6x. Then 9 times 1 is 9. Okay? Again, in one fell swoop, we are where we need to be. Okay? Okay, we're good with that. Okay? Now let's go to the bottom of page 211. There is a complex conjugate zeros. Okay? Read that for me. Okay, so suppose that f of x is a polynomial function with real coefficients. Okay, now there's with real coefficients. If they're real coefficients, then a and b are real numbers. Then if a plus bi is a 0, then a minus bi has to be a 0 also. Okay, so if you think about it, how do you get complex roots? How do you know to get to plus or minus square root of 5i? How do you know that? Where do you get that from in your experience? Lila, where do you get those from?
Where do we get complex numbers from?
Yeah, complex roots from. Yeah, where do you get them from? Where have you seen them?
In algebra.
Okay, what part of algebra?
Like tan and cosine, I guess. I don't know, like with roots.
Don't, I mean, for the most part, where you get these things is when you do a quadratic equation, right? You do a quadratic equation and you have something like x squared minus 2x plus 4 is equal to 0. X is going to be equal to negative, 2a, right? 2 times a minus b, right? Minus b plus or minus square root of b squared minus 4 times a times c, right? And you get 2 plus or minus square root of minus 12 over 2. And this is where you get your eyes, right? This is where you get the complex numbers, right? This is where you found them before, okay? This is probably the only place where you found them actually while you were doing work, okay? All right, so this is where you get them. So as you can see, if the plus is going to be a solution, the negative has to be a solution too. And that's all it's saying, okay? This theorem here is saying that if you find, if you get 2 plus root 3i, if this is a solution, then this guy has to be a solution too. Okay, if the plus is the solution, then the negative, which is the conjugate has to be a solution too. Okay, so that's what that's saying. Let's go ahead and flip the page. Go to page 212, look at example number 2. In example number 2, I have write a polynomial function with of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. So I have -3, 4, and 2 minus I, okay? So, since we just said that from the complex difference, so if this is a root that the conjugate has to be a root also, then I know that the plus I has to be a root also. So I have these 4. So I need to come up with a polynomial that has these 4 as a root. So the way I'm going to do that is I'm going to just go ahead and put them into linear factorization mode, right? Because if I get here, I get the -3. From 4, I get -4, I get the 4. And then I'm going to get x minus 2 minus I, and then I'm going to get x minus 2 plus I. Okay? So the hard part is not going to be this. This will be easy. This is going to be the hard part, right? This is going to be the hard part. Okay, so let's do the easy part first. If I multiply these two together, I get what? X squared, I get plus 3x minus 4x, so it's minus x. 3 times minus 4 is minus 12. That was easy. Now over here, I have to do this, right? So, the first one's easy, x squared, right? Then I'm going to multiply this guy to get the x's. So the first one, I'm going to get minus 2 minus I number of x's if I multiply these two together. Then when I multiply these two together, I'm going to get minus 2 plus I numbers of x's, right? So if I add these two together and find out how many x's I'm going to get, what am I going to get? I'm going to get minus 2. So if I take away this, I'm going to get minus 2 plus I minus 2 minus I, right? If I propagate the negatives through, this is what I'm going to get. So if I add these two together, these cancel out, I end up with minus 4x. Okay, that's how many x's I'm going to get. Right, now let's do the constant. The constant is this guy times this guy, right? And negative times a negative, so it's positive. But I'm going to get positive, I'm going to get 2 negative I, 2 minus I times 2 plus I on the constant, right? So it's going to be what? 4. And then I get minus 2i and plus 2i, those cancel out. Then I get minus I squared, minus I squared. Okay? So that's what I get for the constants. Okay? Minus I squared is what? This is minus 1, so it's plus 1. So in the end, this is going to be 5 here, right? So this one, I can erase this and call this 5. Okay, so we have done the hard part here, right? This here is the hard part. We just did that. Okay, we'll do this a couple more times just to make sure that you understand it. Now let's go ahead and do this out and find out what we're going to get. We're going to get x to the 4th, x to the 3rd. How many different ways are there to get x to the 3rd? This guy times this guy, which would be minus 1. This guy times this guy, which would be minus 4. Add them together, I get minus 5. I get minus 5x cubed. X squared, how am I going to get x squared? I get this guy times this, I get plus 5. This guy times this, I get minus 12, so that's minus 7 altogether. There's one more though. I have minus 7 so far. If I multiply these two together, I get plus 4, right? So it's minus 7 plus 4, it's going to be minus 3. Okay. X's, I get minus 1 times 5, well, it's minus 5. Then I get this guy, I get plus 48. Right? 48 minus 5 is going to be plus 43. Then you have this guy times this guy, which is going to be negative 60. Okay, now the way I'm doing this might seem pretty complicated at first, okay? You feel free to go ahead and do it the old-fashioned way and do them all out, and then you can go ahead and combine them together, and you'll get the same thing, okay? But again, I'm trying to stretch your abilities here a little bit, okay? This is something that I think that is completely within you guys' capabilities to do, okay? Otherwise, I wouldn't be teaching this, okay, this way, okay? Yeah, the old method, the method that you know, that you're familiar with, is just to do every single one out, right? And then collect all of them, right? I figured, you're going to miss the possibility or probability of missing something up during that is about the same as messing something up the way I'm doing it anyway, right? Okay, so that's how you do that, okay? So again, as promised, let's see if we can do another one and see if we can get better at that 2 minus I and 2 plus I stuff, okay? Example number 3. Example number 3. I have write a polynomial function which has a real coefficient whose zeros include 1 plus 2i, and 1 minus I, right? Okay. So, since this is a root, I know that 1 minus 2i is a root also, right? So 1 minus 2i is also a root. 1, and they also gave you what? 1 minus I. So 1 minus I is a root, therefore 1 plus I has to be a root also. Okay, so let's write this out. X minus 1, 1 plus 2i. And then I have 1 minus 2i. And then I have this guy, x minus 1 minus 1i, x minus 1 plus 1i. Okay? There's nothing to do with this one. That one stays the same. Okay, now let's see if we can do this guy here. Okay. First off, I'm going to get x squared. Now let's at the x's. The x is going to be this guy times this guy, and this guy times this guy, right? If I add them up, I'm going to get minus 1 plus 2i and minus 1 minus 2i. So I have to add these two together. So if I do the negatives out, I get this guy here on the top, this guy on the bottom. And add these two together, these two cancel out, I get negative 2. So negative 2x, right? And then I'm going to multiply on the constant part, I'm going to multiply this guy with this guy. Okay? So then I get 1 plus 2i times 1 minus 2i, which is going to be equal to 1. Over here, I get plus 2i, minus 2i, they cancel out. You know, multiply these guys together, I get minus 4i squared. I squared is negative 1, so it's going to be plus 4, 5. So this here is going to be 5. Okay? Okay, let's go ahead and do this one now. Again, the top part is the same, x squared. The x's, I get this guy, and then I get this guy, right? So I'm going to multiply these two together. So how many x's do I have? I have minus 1 plus I x's. If I multiply these two together, I get minus 1 minus I. If I do the minuses out, I get that. So if I add these two together, I'm going to get negative 2x. Now I'm going to do the multiplication of the constants. I'm going to multiply the two ends right here. So minus times minus is a positive. 1 minus I, 1 plus I, 1. And then I have minus I plus I. They cancel out. Minus I squared. Minus I squared is plus 1. So 1 plus 1 will be 2. So there's your answer. Okay, now I have to do this out. So now I have a choice, right? I can either do this guy to this guy and then do times this, or I can do this guy to this guy and then multiply those two together and do this. Okay. I would rather not do this guy to this guy, right? Just because, well, I guess we could do it that way. It doesn't really matter. Okay, so let's go ahead and do this guy to this guy, okay? If we do that, we get what? X minus 1 stays the same. X squared times x squared is x to the 4th. X to the 3rd, I get this guy times this guy, which is minus 2. This guy times this guy, which is minus 2 again, so it's minus 4 altogether. Minus 4x to the 3rd. X squared, I get this guy times this guy, which is plus 2. This guy times this guy, which is plus 5, so I have plus 7 altogether. But then I have this guy, plus 7. Now I'm going to go plus 4, so it's going to be plus 11. Plus 11x squared. Okay, then x's, I get negative 2 times plus 2, negative 4. I'm going to have this guy, negative 5 times negative 2, which is negative 10. So negative 10 and negative 4 are negative 14. 2 times 5 is 10. Okay. Again, feel free to just do it all out the old-fashioned way, okay? And then combine them all together. That's up to you, okay? So for the last, now I can get x to the 5th is the highest I can get. X to the 4th, I'm going to get minus 1. And then I'm going to get minus 4 altogether. So minus 4 minus 1 is going to be minus 5. So I get minus 5x to the 4th. X cubed, how do I get x cubed? So this times this is 11. This times this is plus 4. So I'm going to get altogether plus 15. Okay, then x squared I get negative 11. And I get this guy, which is going to be what? So I had negative 11, negative 14, so I do negative 25. We're doing, we need x squared, right? X squared, negative 11, yeah, negative 25. X squared. X's, I get this times this is 10. This times this is plus 14. So I'm going to get what? Plus 25x. Constant is negative 1 times 10 minus 10. Okay. Is that correct? Let's go ahead and verify that I'm good here. Oh, this is 24. I'm sorry, not 25, 24. Okay, so there you go. All right. All right, let's go ahead and take a break here, and then we'll come back. Let me go ahead and